We tend to think of history as a straight line. We imagine the past as a dark, simplistic place, a slow, uphill climb from mud huts and stone axes to the shimmering glass and steel of the modern age. We like to believe that we are the smartest humans to ever live, standing on the summit of thousands of years of progress. But what if that perspective is wrong? What if history isn't a straight line but a cycle? What if there were moments in the ancient world where humanity stood on the precipice of an industrial revolution only to stumble, lose their footing, and fall back into the dark? Today, we are going to look at the inventions that shouldn't exist. We are going to explore the forgotten technologies of the ancient world, machinery, materials, and concepts that were so advanced they would have been considered impossible for the people who used them. From computers made of bronze to engines powered by steam, these are the lost blueprints of our ancestors. Our first stop takes us to the year 1901, off the coast of a tiny, windswept island in the Aegean Sea. Sponge divers were exploring a shipwreck when they pulled up a lump of corroded, calcified bronze. It looked like nothing, just a piece of junk. But when archaeologists cleaned it, they realized they were looking at the greatest scientific discovery in history. It was the Antikythera mechanism. Imagine a clock. Now imagine that clock was built not in the 18th century, but around 150 BCE. This device was a complex system of at least 30 intricate bronze gears housed in a wooden box. It was a mechanical computer. It tracked the movements of the sun, the moon, and the planets. It predicted solar and lunar eclipses with terrifying accuracy decades in advance. It even tracked the 4-year cycle of the ancient Olympic Games. We had no idea the Greeks had this level of gearwork technology. We thought it appeared in Europe during the Renaissance, more than 1,000 years later. When we look at the Antikythera mechanism, we aren't just looking at a fancy calendar. We are looking at a proof that the ancients had mastered complex mechanical physics. If they could build this, what else could they have built? And why did the knowledge of how to create such precision instruments vanish for a millennium? If that doesn't challenge your view of the past, let's look at something even more mysterious. In the 1930s, in the ruins of a village near Baghdad, archaeologists found a clay jar containing a copper cylinder and an iron rod. They called it the Baghdad battery. When researchers filled the jar with a mild acid like vinegar, it generated a small electric current. Was this a battery? Was the ancient world using electricity? The jury is still out. Some argue it was just a storage vessel for scrolls. Others argue that it was used for electroplating, putting a thin layer of gold on silver objects. If it was a battery, it's a terrifying thought. How many other applications of electricity were lost? Did they use it for medical purposes, for lighting, for parlor tricks? The Baghdad battery stands as a tantalizing what-if, a small, simple object that suggests a doorway into a world of energy that we are only just beginning to understand. But let's move from the mysterious to the documented. Let's talk about the steam engine. We associate the steam engine with the Industrial Revolution of the 18th century. We see it as the invention that broke the back of feudalism and launched us into the modern era. But what if I told you the Romans had a steam engine in the 1st century? It was called the Aeolipile, invented by Heron of Alexandria. It was a simple sphere mounted on an axis with 2 bent nozzles. You put water inside, boiled it, and steam shot out of the nozzles, causing the sphere to spin at high speeds. It was a steam-powered turbine. Heron used it to impress the locals and demonstrate the power of steam, but he never used it to do work. He never used it to pump water out of mines, to grind grain, or to power machines. Why? Because the Roman Empire had an unlimited supply of cheap labor, slaves. In a society where human life is inexpensive, there is no economic incentive to invent labor-saving machinery. The Aeolipile was a scientific toy. It was a breakthrough of genius trapped in a society that didn't need it. Imagine a world where the Roman Empire decided to industrialize. Imagine Roman steam trains, Roman factories, Roman power grids. The Aeolipile is the ultimate monument to the idea that technological progress isn't just about the invention. It's about the culture that decides how to use it. And sometimes the lost technology isn't a machine, but a material. Look at the concrete we use today. It's the backbone of our infrastructure. But but it's notorious for cracking and eroding. In just a few decades, modern concrete starts to degrade, especially in salt water. Yet, the Romans built harbors, piers, and breakwaters 2,000 years ago that are still standing today, battered by the ocean, essentially unchanged. For centuries, this was a mystery. How did they do it? It turns out their recipe was a stroke of chemical genius. They mixed volcanic ash with lime and seawater. This created a rare mineral that actually grows stronger over time when exposed to the ocean. The chemical reaction creates a self-healing structure. The more the sea hits it, the tighter the concrete becomes. We are only now, in the 21st century, trying to reverse engineer Roman concrete to build more durable cities. They weren't just building for the day, they were building for eternity. And then there is the legend of Damascus steel. During the Crusades, European knights encountered swords from the Middle East that were unlike anything they had ever seen. These blades were so sharp they could slice a silk scarf in midair, yet so flexible they could be bent 90 degrees without breaking. They had a distinctive watered pattern on the surface. For a long time, the secret to making this steel was lost. Modern metallurgists have spent decades trying to replicate it. Some studies have even found evidence of carbon nanotubes, the cutting edge of modern materials science, embedded in the structure of these ancient blades. How did 12th century blacksmiths create nanotechnology in a forge? It remains a subject of intense debate, but it proves one thing. Our ancestors were masters of chemistry on a molecular level, even if they didn't have the words to describe what they were doing. So, why did all of this disappear? Why did the knowledge of gears, steam, chemistry, and concrete fade away, leaving us to reinvent them hundreds or thousands of years later? The answer is rarely a single cataclysm. It's usually a slow rot. It's the loss of libraries, like the one in Alexandria. It's the collapse of trade networks that allowed scientists to share ideas. It's the fall of empires that funded research. It's the transition from a society that values inquiry to one that values tradition. We like to think that progress is inevitable, that once we learn something, it stays learned. But history tells us otherwise. Knowledge is fragile. It lives in the minds of the people who hold it. And when the civilization that supports them crumbles, that knowledge can vanish in a single generation. These forgotten inventions aren't just curiosities, they are warnings. They are reminders that we aren't the first humans to stand at the peak of genius. We are the survivors of a long, often broken tradition of human curiosity. We stand on the shoulders of giants, but we also walk on the graves of their lost breakthroughs. Maybe that's the most humbling lesson of the ancient world. We aren't necessarily the masters of the future. We are just the current stewards of human history. The machines of the ancients, the computers of bronze, the engines of steam, the steel of nanotubes are waiting for us to understand them, not because we need them, but because they remind us of what we are capable of. History isn't a straight line, it's a spiral. And maybe, just maybe, the next great invention of the future is something we've actually had all along, buried deep in the past, waiting to be rediscovered.